Again, I can't have crazy exponents on my e's, so I'm going to let u be my crazy exponent. And then when I take the derivative of it, of course that'll be a negative 3x to the negative 2, so over x squared. And then I keep my fingers crossed and I look over there and say, do I have all of that? Well, I got most of it. I'm just going to have to slip in a little negative 3. But if I do that, I'll need a negative 1/3 out front. And then at the same time, I like to change the x bounds to the u bounds so I don't have to substitute in and then out. So if x is the lower bound, which is 1, then u will be 3. And if x is the upper bound, which is 3, then u will be 1. So now my integral goes from 3 to 1, and I'll have e to the u du. And I don't like those bounds being upside down. I like the lower one on bottom. So in order to switch them, of course, remember I have to simply negate it, and it already is a negative, so now it will be a positive, and then I make the switch. Oops, e to the u, not u to the e. And then the antiderivative of e to the u is e to the u. And I don't need the plus c because I have definite boundaries. Whee! So, plugging in, I get 1/3, that's a third, e to the third, minus 1/3 e to the first. If I want, I could pull out the 1/3. So I'd have 1/3 of e cubed minus 1. Either of those, remember, it's dictated by multiple choice. On this one, if I want to solve the differential equation, I want to get back to the original. And starting with second derivative, I know that I could get to first derivative if I take the antiderivative of second derivative. How many times can we say the word derivative? Which means I'm taking the antiderivative of plus 1/2. I'm going to distribute that 1/2. And then I'm going to split my terms. So, oh, you know what I think I'm going to do? I'm going to put the 1/2 out in front. I don't need it in there. So I have e to the x, and then another 1/2 e to the negative x. Now that negative x is a problem, because I can't have anything other than e to the x or e to the u. So I can integrate this first piece, which will be 1/2 e to the x. But on this second piece, I'm going to have to let u equal negative x. So du will be negative dx, which means I'm going to have to slip him a little negative, and then I'll slip a little negative out in front. So I'm now, I guess could have made that a minus. I now have e to the u du. So all of this, of course, remember the first piece I already integrated, and then minus 1/2, which will be e to the u plus c, and that e to the u is really e to the negative x. So remember, this is first derivative, and I have a value for first derivative. I know if x is 0, then I get 0, which means when I plug in, I'm going to have 1/2 e to the 0 minus 1/2 e to the 0 plus c equals 0. So it'll be 1/2 minus 1/2 plus c equals 0. So c equals 0.